Uh, so the third question is from area under the curves. Let's start with plotting the curve. We have been given fx is a cubic, and at x equals to 0 it's 17 by 36. At x equals to 1 it's 1 by 3 minus 1 plus 5 by 9 plus 76, which becomes 3 by 9 minus 1 by 9 is 13 by 36. It's something like this: 1 comma 17 by 36, 0 comma 13 by 36. And its derivative there is x square minus 2x plus 5 by 9, which is x minus 1 squared minus 4 by 9. So is it always negative? Yeah, it is always negative. So this in 0 to 1, so this should be a decreasing function, I think. Sorry, at 0 it's 17 by 36, and at 1 is 13 by 36, so it's a decreasing function in this interval. Let's draw something. Draw it like this. Okay, so consider the square 0 comma 1 to 0 comma 1. It's something like this, and this is our square. The region above the curve, which is y greater than fx, is the green region. So let's say this is the green region. Area below the curve is the red region. LH, so LH is the line y equals to h. So let's first find the area of the green region, or say the area of the red region. Area of the red region becomes 0 to 1 fx minus the line y equals to 0. So y equals to fx minus y equals to 0, that becomes x cubed by 3 square plus 5x by 9 dx. This is x to the power of 4 by 12 x cubed by 3 square by 18 plus 17 36. So this becomes 0 at 0. At 1 this becomes 1 by 12 plus 5 by 18 plus 17 by 36. So this is minus 1 by 4. These two 5 by 18 is 10 by 36 plus 17 by 36, 27 by 36, which is 3 by 4. 3 by 4 plus minus 1 by 4 is half. So area of red region is half, which means that the area of green region is also half. So area of this region is half, the area of this region is half. So let's find the area of red region below the line H as a function of H. Fx was x cube by 3 minus x square plus 5x by 9 plus 17 by 36. F prime was x square minus 2x plus 5 by 9, which is x minus 1 squared minus 4 by 9. At 0, this is positive. So this line first increases, and at 1 by 3, this is 0, after which this is negative. So the graph is in fact something like this. This is the red region. This is the green region. So for the line LH to bisect the area, the green area, we'll need the area above the line to be 1 by 4. As this is 1, this needs to be 1 by 4, which means this coordinate would be 3 by 4, and as it is greater than this point, we need to find the value at this point, value of the function fx at the point 1 by 3, to make sure that f1 by 3 is less than 3 by 4. So f1 by 3 is 1 by 81 minus 1 by 9 plus 5 by 27 plus 17 by 36. These two become 2 by 27. So this is 6 by 81, 7 by 81 plus 17 by 36. Let's subtract 3 by 4 from this. It becomes 7 by 81 minus 10 by 36. So obviously this is less than 0, which means the function f of 1 by 3 is less than 3 by 4. And f1 by 3 is the local maxima of the function in 0 to 1. Which means at the line at h equals to 3 by 4, LH will bisect the green area. So we don't get any option from that. And similarly, for the line h equals to 1 by 4, this line will bisect the red area. So we get option B. And now we'll have to check for option C and D. And notice that if option C is correct, option D is correct, because the same line will satisfy both the conditions. So we are looking for a line like this such that this area is equal to this area. To solve for this, we'll have integration of 0 to, this is y equals to h. Let's say this point is f inverse of h. Let's say this is c. You have integration 0 to c fx minus fc equals to integration of c to 1 fc minus fx dx. This is the condition which it satisfies. This is the c for which we need to solve. We'll get integration 0 to c fx minus fc dx minus integration c to 1 fc. So that gives us integration 0 to 1 fx minus fc dx equals to 0, which gives us which is, as we know, half. So we need that the c, in fact the fc, which satisfies the condition that it bisects the, which satisfies the condition that the area of red region above that line is equal to area of the green region below that line, is half. So h is half, which means c and d are correct. Because notice that fc is this line which we are required to find, this line fc. We tried to solve for c, but instead we got the value of fc, because when this comes here, when we brought this side to the left, this whole expression to the left, we got 0 to c fx, and by distributing this minus, we'll get this minus and this plus. So we'll get c to 1 fx dx added to it, which will become 0 to 1 fx dx. And similarly 0 to c fc and c to 1 fc, both are negative, so they'll add up like this, and we'll get 0 to 1 fc, which becomes fc. Integration of 0 to 1 fc dx becomes fc. This is 0, so we'll get 0 to 1 fx dx equals to fc, and 0 to 1 fx dx is the area of this red region, which we know is half. So that gives us fc is equals to half, and fc equals to fc is this y coordinate of this line, which is h. So h equals to half. So c and d both will become correct, because half lies in 1/4 to 2/3. Area of green region above this is equal to area of red region below this, and as this plus this equals to this this region, or rather let's say this region plus this region equals to this region plus this region. So if this region, area of this region is equals to area of this region, then automatically area of this region will become equals to area of this region. So if C option is correct, then D option is correct.